Okay. So in the last class we studied about buffer solutions. Now we are discussing about solubility of a salt. Okay. So we are discussing about sparingly soluble salts. Sparingly soluble means the salts which are very less soluble, they are called as sparingly soluble salts. Very less dissolving capacity is there. It means most of the salt is not dissolved. Very less amount of salt is dissolved. Okay. So first of all, how can I define solubility? Okay, ma? So it is the amount of salt dissolved in 1 liter of solution. 1 liter of solution. Okay, ma? So if you take 1 liter of solution, then how much amount of salt is dissolved? That is called as solubility of the solution. Are you able to understand? So therefore, what can be the units? Units of solubility, what can I write? Units of solubility? Grams per liter is what I have to write, no? Grams per liter. So how much amount of salt is soluble in 1 liter of solution? So the unit is grams per liter. Are you able to understand? For example, if I take one salt AB, in aqueous solution it dissociates into A plus and B minus. Let us consider this is a salt. Are you able to understand, ma? So salt dissociates into A plus and B minus in aqueous solution. Then at equilibrium, can you say how can I write its equilibrium constant, ma? Do you remember? That's it. So equilibrium of the solution is nothing but concentration of products divided by concentration of reactants. This is called as K equilibrium, no? Are you able to understand, ma? So the product of concentration of reactor products to the concentration of reactants is called as K equilibrium. Now to this K equilibrium, if I multiply the concentration of reactants, then it becomes concentration of products. Are you able to understand? Now what is this one? K equilibrium, it is a constant. Concentration of reactants is also a constant. Are you able to understand? So this is the salt which was dissolved. But why I am writing concentration of AB is also constant? Some of the salt has already dissolved, no? But we are writing concentration of this reactant, this salt is also a constant. What can be the reason? See, at equilibrium, some of the salt has definitely dissociated, no? Some of the salt has dissolved. But we are writing concentration of this salt is a constant. Why? Reason is already we have written, no? Very less amount of salt is soluble. Okay? So the concentration of this salt, it almost remains a constant because very less amount of salt has been dissolved. Are you able to understand? So why it is remaining a constant? Because what is the reason that concentration of this salt is remaining constant? Because very less amount of salt is dissolved. Are you able to understand what is the reason? So this product of K equilibrium and the concentration of this salt, combinedly it is called as, I will write here. So K equilibrium multiplied by the concentration of this salt, combinedly this product is called as Ksp. Okay? And what is this Ksp? This is called as solubility product of the salt. Solubility product of salt. Are you able to understand? So what is meant by Ksp here? Ksp is the product of equilibrium constant multiplied by the unchanged concentration of the salt. Are you able to understand? So this product itself is called as solubility product, and Ksp is again, it is also a type of equilibrium constant only. Okay? Equilibrium constant depends on what? It depends on temperature, no? So therefore this solubility product also depends on temperature only. So this is another form of equilibrium constant which measures the solubility of the salt in a solution. Are you able to understand, ma? So right now. So therefore what we write that, so Ksp is another type of KSP is another type of equilibrium constant. Okay, ma? So KSP also depends on what? KSP also depends on temperature itself. Okay? Just like equilibrium constant depends on temperature, solubility product also depends on temperature itself. Are you able to understand? So K equilibrium multiplied by concentration of AB is nothing but KSP. So therefore KSP will be equal to this one number. So concentration of A plus and concentration of B minus. So that product is called as solubility product of a salt. Are you able to understand? Very easy concept. Okay. Already we have studied K equilibrium number. So here K equilibrium is multiplied with what? K equilibrium is multiplied by concentration of the salt. That's it. Okay. So therefore I will write KSP is nothing but K equilibrium multiplied by concentration of salt. This is equals to the ionic product of concentration of ions. This is how I can write. Okay. So what is A plus and B minus? They are concentration of ions. So the product of concentration of ions is nothing but ionic product. Ionic product means what? Ionic product means concentration of ions. That's it. Are you able to understand? But this is called KSP at which condition? This is called KSP at equilibrium. Are you able to understand, ma? So these are ions only, no? Concentration of A plus and concentration of B minus, they are called ions. And this is the product of ions. So therefore this is called ionic product. But the same ionic product you will call it as KSP in which condition? At equilibrium. Are you able to understand? So therefore this product we can call what? This product we can call ionic product. Okay. And ionic product is called from where to where? From T is equal to 0 to T is equal to infinity. Between any of this time, this is called as ionic product. But the same ionic product is called KSP at which condition, ma? At equilibrium. Okay, ma? When equilibrium condition is achieved, same ionic product is called as solubility product. Are you able to understand the difference? So ఎక్కడైనా సరే దీన్ని అయానిక్ ప్రోడక్ట్ అని అంటాం మనం. కానీ ఈక్విలిబ్రియం దగ్గర ఇదే అయానిక్ ప్రోడక్ట్కి ఇంకో పేరు ఏం పెట్టుకుంటాం మనము? సాల్యుబిలిటీ ప్రోడక్ట్. దట్స్ ఇట్. ఇస్ ఇట్ క్లియర్? మేక్ నోట్ అప్ టు హియర్. కాసేపు ఫ్యాన్ అండి, చచ్చిపోతాం లేదంటే. సిమ్. సో నౌ we are trying to derive a relation between KSP and ESMA. What is meant by KSP? Solubility product, and S is called as solubility. What is meant by solubility product? Just we have understood, Nama. And what is meant by solubility? The amount of salt which was dissolved in 1 liter of solution. So I want to write a relation between them. Okay, now see here. So this is a strong acid, HCl. It can dissociate into H plus and Cl minus. Similarly, NaOH is a strong base. It can dissociate into Na plus and OH minus. So when these two are added up with each other, then H plus and OH minus combine to form water, and Na plus and Cl minus they combine to become salt. This is what is happening, Nama. So NaCl is a salt. So therefore, for example, if I take one more salt, and what is the salt I am taking? AmBn. It means M ions of A is present, N ions of B is present. So this is a salt which I am taking. For example, if you take CaCl2, then what is the meaning of this one? In this salt, 1 ion of Ca is present, 2 ions of Cl2 is present. That is the meaning of this one, Nama. So if this salt is dissociated, it forms into Ca plus and Cl2 minus, or 2Cl minus. You can write like this also. This is how it will dissociate, no? Similarly, I am taking a salt in which M ions of A is present and N ions of B is present. So therefore, it dissociates into like this. It dissociates into M into A power N plus, N into B power M minus. Can you say why it has dissociated like this, ma? Can you say why I got A power of N plus here? A power of N plus why I got, can you explain, anybody? Chapandi. Sima, to this ion of A, how many ions of B are attached? N ions of B are attached, no? So when N ions they get separated or dissociated, then what is the sign it will get? It will get N plus only, no? Are you able to understand? Similarly to B, how many ions of A are attached? M ions of B are attached. So when they get dissociated, what is the power B will get? B will get the power of M minus. Are you able to understand? Clear, no? So therefore, at t is equal to 0, what is meant by t is equal to 0? When I have put this salt in water. Okay? When I just put this salt into water, still salt has not dissociated, no? It has not dissolved still. So therefore, the amount of salt present is yes. And the amount of A plus ions present is 0. And the concentration of B plus ions is also 0. At which position? When t is equal to 0. Are you able to understand? Ma? Now after the salt has completely dissolved, now there is no salt present, no? Individually salt is not present. It is separated into ions. So how many ions of A will be formed? M into S. Clear, no? Because M ions were present, no? Similarly, how many ions of B will form? N into S, where S you can call it as solubility of this salt. Are you able to understand? What is S here? S is called as solubility of the salt. Are you able to understand what is happening? Clear, no? So why we got N plus and why we got M minus, that first of all you have to understand. And why solubility has become M into S, N into S, that also you should understand. Okay? Now therefore, after writing this equation, now I want to write Ksp of the solution, solubility product of the solution. So what is the formula to calculate solubility product of the solution? So concentration of AN plus to the power of its stoichiometric coefficient. What is its stoichiometric coefficient? M. So AN plus to the power of M. This is how we write concentrations, no? Clear, number? Similarly, what is the concentration of B? Bm minus to the power of stoichiometric coefficient of N. Okay? So Bm minus to the power of what? To the power of its stoichiometric coefficient. Clear, no? So this is the concentration of A ion. This is the concentration of B ion. In terms of solubility, what I can write? Instead of concentration of A ion, I can write M into S, no? Similarly, instead of concentration of B minus ion, I can write N into S. Is it clear, ma? So M into S to the power of M, N into S to the power of M. So therefore, M to the power of M, S to the power of M, N to the power of N, S to the power of N. So therefore, if you combine them in an equation, this is the equation which I get. Are you able to understand, ma? M to the power of M, N to the power of N, S to the power of M plus N. So this is the relation between solubility product and solubility of a particular salt. Okay. For example, if I do some calculations, let us see how we can do the calculations, ma. Okay. Example, calculate the Ksp of NaCl salt. Can you say how can I write? Calculate the Ksp of NaCl salt. Okay, write down. So what is the formula of Ksp, ma? Ksp is equals to M power M multiplied by N power N multiplied by S power of M plus N. This is the formula, no? Okay. So in NaCl, how many Na plus ions will be there? Only one will be there. Similarly, how many Cl minus ions will be there? Only one. So therefore, M value is 1, 1 power 1 multiplied by 1 power 1 multiplied by S power 1 plus 1. That's all. No? So therefore, what is Ksp? Ksp is equals to 1 into S square. So this is the relation. Okay. This is how I can calculate Ksp of a salt. Are you able to understand? Similarly, let us write one more example. For example, CaCl2. For this one, try to calculate Ksp. చేయండి త్వరగా. ఊపుకుంటే పైన ఉండే ఇంట్రెస్ట్ చేయడం మీద లేదు మీకు. కానండి. Solubility Ksp of CaCl2. S cube. Total calculation? Okay, ma? So what is the formula of Ksp? M power M multiplied by n power n multiplied by s power of m plus n. This is the formula, no? So how many ions of Ca are present? Only one ion. So therefore I will write 1 to the power of 1 multiplied by how many ions of Cl2? 2 ions are there. So how can I write 2 to the power of 2? Understood, Nama? Multiplied by s power of 2 plus 1. This is how we have to write. Okay. So therefore what is the answer I got? It is 4s cube. So this is the Ksp value of this particular salt. Are you able to understand how we are calculating? So if you don't understand all this, no problem. Just you remember this equation. Ksp is equals to m power m multiplied by n power n multiplied by s power of m plus n. Okay. Where m indicates the number of ions in first ion, number of ions in the second ion, and s to the power of sum of both ions. That's it. Clear? Right. Okay, ma? So see. So this is the next question, ma. Calculate the Ksp of a general salt AX By. What is meant by AX By, ma? X ions of A is present, Y ions of B is present. That is the meaning of this one. So how can I write its Ksp? Ksp is equals to m power m multiplied by n power n multiplied by s power of m plus n. Okay, ma? మూడో తరగతి లెక్కలన్నీ ఈ కూడా చేయలేకపోతే ఎందుకు మీరు ఇంకా చేయండి. So how many ions of A are present? X power of x only. Okay, ma? How many ions of B? Y to the power of y only multiplied by s power of x plus y. That's all. For any salt you can use this formula. Are you able to understand, ma? So let us write one more question. So calculate the solubility of AgCl salt. Okay, ma? So Ksp is given as 1 into 10 power minus 14. Do the calculation. Calculate the solubility of AgCl salt. Ksp value is given. Now I want to calculate solubility. ఏందో మీ ప్రాణాలకు ఐఏఎస్ క్వశ్చన్ ఇచ్చినంత ఎక్స్ప్రెషన్ పెడతారు ఫేస్లో. ఓకేమా? హౌ టు క్యాలిక్యులేట్ Ksp? m power m, n power n, s power of m plus n. Clear, nama? So 1 power 1, s power of 1 plus 1. So Ksp is equals to s square. So s is equals to root of Ksp. K value is already given, nama, 1 into 10 power minus 14. So therefore solubility is equals to 1 into 10 power minus 7. That's all. That is my answer. Okay. Okay, see, ma. So now we are checking the solubility in such a solution where some ions are already present, ma. Now until now we were checking solubility in water, no? We were checking solubility in water. We take some salt, we try to dissolve that salt in water, then we have calculated the methods of checking its solubility. Now I am checking the solubility of a particular salt in which already there is some solution in which some common ions are present. Are you able to understand? It means that, Sima, let us try to understand by taking this example. I want to check the solubility of AgCl salt in 0.1 molar NaCl solution. Okay? I am not checking solubility in water now. I am checking solubility in another solution where already there is some common ions which are present. Now here can you say which is the common ion which is present, ma? Cl minus is the common ion. So in AgCl also we have Cl minus. In NaCl also we have some common ion. Are you able to understand? So in this condition, how can I check the solubility? Let us see. Okay. So what is the given salt here? Given salt is AgCl salt, no, ma? Okay. So this dissociates into what? Ag plus and Cl minus. Okay. So therefore at T is equal to 0. That is immediately when I put this AgCl in this NaCl solution, that time is called T is equal to 0 only, no? Before dissolving starts, that time is called as T is equal to 0. Clear? So at T is equal to 0, the total salt is yes, solubility is yes, or the amount of salt which is ready to dissolve is S. Still it has not dissolved. And Ag plus is how much? 0. Cl minus is how much? Cl minus is 0.1. Why I have taken Cl is 0.1? Because in this solution already 0.1 mole of NaCl is present, no? That is the meaning of this one, no? And this NaCl, I can divide this one into Na plus and Cl minus. So 0.1 molar of Na plus is present, 0.1 molar of Cl minus is also already present. Okay, so therefore at T is equal to 0. T is equal to 0 means what? Before this salt dissolves, already there is some Cl minus which is already present. So that you have to include at T is equal to 0. Are you able to understand? So in the previous condition, when salt was dissolved in water, Ag plus was also 0, Cl minus also was 0, but here Cl minus is not 0. That is the only difference. Arthamautundi kada difference? Clear nama? So therefore at equilibrium means what? After this salt has completely dissolved, now what I can write? What is the amount of AgCl ma? 0. Now AgCl is not present because it has dissolved in this solution. So how much amount of Ag plus is formed? S. Because here also 1 mole, this is also 1 mole nama. If this is S, this is also S. Now what about the amount of Cl minus? So in addition to 0.1, another S is formed. That's all, no? Already 0.1 is present. In addition to this one, again S moles of these ions are formed. Okay, 1 mole of salt is giving 1 mole of Ag plus and 1 mole of Cl minus. So S salt has disappeared. So S moles of Ag plus has appeared and S moles of Cl minus also has appeared. I did not explain all this, no? I hope you know all this. Clear, Nama? Okay. So therefore, now how can you write Ksp ma? Ksp of a salt, how can I write? Concentration of A plus multiplied by concentration of B minus. That's all, no? So therefore, concentration of S multiplied by concentration of 0.1 multiplied by S. This is Ksp, no? Are you able to understand, ma? Ionic product is nothing but Ksp. Ionic product you can take at any time. But ionic product at equilibrium is called Ksp. Gurtunnayi kada? So do the calculation. So Ksp is how much? Ksp is equals to S multiplied by S into 0.1. So total how much, ma? S square multiplied by 0.1 into S. This is how I can write. This is the Ksp value which I got. So therefore Ksp is equals to S square multiplied by 0.1 S. Approximately I can write 0.1 S only. Can you say what is the reason? Try to say what is the reason of this one. Because S value is basically very less, no, ma? What is S? S is the small amount of salt present in 1 liter of solution. So S value is much less than 1. S value ne chala chinnadi. S square value, or I will write like this, S is 2 times less than 1, but S square value, it is much less than 1. Understood, no? 1 by 2 is less than 1, no? 1 by 2 is less than 1. 1 by 2 whole square, it is very small when compared to 1. Are you able to understand? So therefore, when compared to 0.1 S square is a very small value. Okay? Or you can say S square is negligible. So therefore, instead of S square into 0.1 S, just I am writing 0.1 into S. Is it clear, ba? So therefore, solubility is how much? Solubility is Ksp divided by 0.1. So this is my answer. Okay? So if Ksp value in this condition, if I take it is 1 into 10 power minus 14. So substitute here. So Ksp is 1 into 10 power minus 14 divided by 0.1. So how much it will be, ma? 0.1 means 1 by 10, no? 1 by 10 goes to the numerator. So it is 1 into 10 power minus 13. So this is the S value. Is it clear, ma? How to calculate Ksp or S value in terms of in the solution if already there is some common ions. Already common ions unte, that concentration also you have to take at T is equal to 0. Then we know how to do at T is equal to equilibrium. At the time of equilibrium, we know what to do. If 1 mole is disappearing, 1 mole of Ag plus is forming and 1 mole of Cl minus is also forming additionally. Is it clear? That's it. So here we have a shortcut formula also, ma, completed up to here. Right. So this is not into ma, by mistake I have written, this is plus only, here also plus, here also plus, this is also plus, this is also plus. Clear? Now see. So see ma, whatever equation I got here, this same equation I can use as a shortcut in 99% of the cases ma. But every time it cannot be correct. So therefore, shortcut method is, instead of doing on this method, just you can use this method ma. So shortcut method is when common ion solution is given, common ion solution is given, then how can I calculate the solubility of this salt? Ksp divided by concentration of common ion. Just if you use this equation in 99% cases, we get correct answer. Okay ma? That means up to NEET and mains levels you can use this formula. Directly you can use this formula without doing all this calculation. Are you able to understand? That is the same result which I got, no ma? Solubility is equal to Ksp divided by 0.1. What is this 0.1? 0.1 was the concentration of Cl minus, no? Are you able to understand? So just if you use this formula also, directly you can get the answer. Okay? But you better use this one. Time ledante idu vadukondi. Okay? That's it. So next, the last concept in this solubility, ionic product. What is meant by ionic product? Already we have discussed, no? What is meant by ionic product? So salt AB, it dissociates into A plus and B minus. Are you able to understand? So the concentration of A plus multiplied by concentration of B minus, this is called as ionic product. Okay ma? And ionic product means from which time to which time? From T is equal to 0 to T is equal to infinity. This product is called as ionic product. And this ionic product is called what? Ionic product is called Ksp. At which position ma? At equilibrium. Okay ma? And what is meant by equilibrium? The amount of salt dissolved and the precipitate which is formed at the bottom, they remain constant. This is called as equilibrium. Okay? So write down the definition of equilibrium first of all. Equilibrium of salt means what? Amount of salt dissolved. Amount of salt dissolved and precipitate. Precipitate at the bottom of beaker are at equilibrium. Okay ma? See ma, for example, in a particular solution, or if you take water and if you are taking one what you call salt, let us consider it can dissolve only 1 gram of salt. Okay ma? I am taking a particular amount of water. This water can dissolve only 1 gram of salt. But if I put 2 grams of salt, what will happen? If I put 2 grams of salt, then what happens? 1 gram will be dissolved and 1 gram will go to the bottom and it will precipitate, no? అర్థమవుతుంది కదా? వాటరు 1 గ్రామ్ సాల్ట్ని మాత్రమే డిజాల్వ్ చేయగలదు అనుకుందాం. మీరేమో 2 గ్రాములు వేసినారు, ఏమవుతుంది? 1 గ్రామ్ డిజాల్వ్ అవుతుంది, 1 గ్రామ్ కిందికి పోయి కూర్చుంటుంది అనమాట. దట్ ఈస్ కాల్డ్ యాజ్ precipitate. So when the amount of precipitate and the amount of salt dissolved, when they remain constant, that condition is exactly what is called as equilibrium. Are you able to understand? Okay ma? So therefore there is some relation between ionic product and Ksp. What is that? Okay ma? So we will write some cases ma. Case number 1 is ionic product is less than Ksp. Okay ma? Ionic product if it is less than Ksp. And what is Ksp? Ksp is nothing but ionic product at equilibrium. Are you able to understand? Then what happens? Then salt is still soluble. Salt is still soluble and precipitate does not form. Precipitate does not form. This is the meaning of this one. Okay, ma? So ionic product, if it is less than Ksp, then what is the meaning of this one? Still there is some possibility for salt to dissolve. And if salt is still soluble, precipitate does not form. That is the meaning of this one. No? Clear now? Similarly, case number 2. What can be case number 2? Ionic product is equal to Ksp. Then what is the meaning of this one? Dissolved salt and precipitate are at equilibrium. Okay, ma? It means their concentrations now does not change. Clear? Third condition. Ionic product is greater than Ksp. Then what happens, ma? If ionic product is greater than Ksp, then what is the meaning of this one? Now salt doesn't dissolve, only precipitate continues to form. Is it clear, ma? So therefore, only precipitate continues to form. Is it clear? So this is the relation between ionic product and Ksp of a salt. That's it. Okay, ma? So make a note up to here. We will discuss